Okay, we'll continue from where we left off. We have the second derivative in factored form, which is 4/9 x to the negative 5/3 times the quantity x minus 2. We saw that's equals 0 when x equals 2, but it doesn't exist at x equals 0. So we have to use both of those places to delineate or to break up the x-axis. They are both similar to what we call critical values when we were working with the first number, with the first derivative. So again, for x equals -1, plugging into the second derivative, x 4/9 -1 to the negative 5/3 is still going to be -1, so that'll be negative, and -1 minus 2 is negative, so that's negative times negative is positive. For x equals 1, we're going to get a positive on the first factor and a negative on the second factor, so that will be negative. Then we'll get a positive on the first and a positive on the second. Positive times positive is positive. And so we're ready to answer the question, for what values of x is this function concave down? It will be concave down for all x greater than 0, less than 2. And that completes part D. So what we're going to do now is go on to graph, use this information to graph in part E. Okay, then the first thing that I have is all of these 4 points over here. We knew the absolute min, the absolute max, and we knew the values at the endpoint. So I'm going to plot those real quick. Okay, so I have those values there. Sorry, the left-hand endpoint was -8, +8. Now we also know that we have a 0 first derivative at x equals -1. And we also know that the function is concave up from -8 to 0. From the second derivative test, when you have a first derivative is 0, second derivative is positive, therefore we have a minimum there, and it's concave up on that whole interval. But we have a vertical tangent at x equals 0, and then the function is concave down from 0 to 2. So I'm going to assume that the first part of the graph looks something like that. We have concave up from -8 to 0. We have a minimum at -1, -3. We have a vertical tangent at 0, 0. And then we have concave down from 0 to 2. And from 2 to 8, we have concave up again. And so the final graph might look something like this. Let's go through the what we do know again. From the concavity, we know from -8 to 0, it's concave up. We know from 0 to 2, it's concave down. We have a point of inflection at x equals 2, and then it's concave up from thereafter. We have a relative minimum at x equals -1, y equals -3. We have the points that we have discussed on the curve, and we have a vertical tangent at x equals 0. Now, my vertical tangent didn't come out too well there, but it would look something like that. Alright, so I fixed it up a little bit, and I think that we have fulfilled all the criteria there, and that would be the solution then to problem number 10.